Welcome again, guys. I am Anurag, and today I'm going to talk about three most genuine but silly mistakes I made as a programmer in first year. Guess what? They all revolve around data types. Trust me, this is not going to be a boring video, so stay tuned. As an enthusiastic programmer, one of the most annoying issues I face while writing a program is when I write a program with totally correct logic, applying the accurate algorithms, and still somehow get the undesired output. And moreover, on top of that, I can't figure out exactly where did I go wrong. Number one of the problems is implicit typecasting in C. Let's check it out. If I have two variables, int a equal to suppose 105 and int b is equal to 8. And if I want to store this divided by this, the quotient. So I take a double value. Double q is equal to a by b. Can you guess what will be the value of q? If you guessed it's 105 by 8 is equal to 13.125 and the variable q will store 13.125, you are totally mistaken. Q will actually store 13.0 here. Why does this happen? Because as we do a by b and a and b are both integers, the number that is stored here is 13. In 13.125, the part after the decimal point is truncated and 13 is stored in a by b. Now as we are storing 13 in a double variable, it transfers 13 to 13.0. It totally deletes this part. So what we need to do to prevent this is we need to externally typecast this part. I'm giving it the correct version. Double q should be equal to double a by b. Now what happens here is this a by b is converted to double first and then it is put in double q. So now q stores the accurate amount 13.125. This was one of the most silly mistakes new programmers tend to do in program. The next one is precision error. Let me show you that. So suppose we have a variable double a is equal to 0.2 plus 0.1. And now we are checking if a equals 0.3, then we should print yes, else print no. Guess what this program will print? Most of you will tell it's yes, because obviously 0.2 and 0.1 add up to 0.3. So this condition shall satisfy and the program will output yes. But that does not happen. You see, as we are giving 0.2 plus 0.1 over here, the compiler gives a precision error because it is not totally sure about what values are there after 2 in this decimal and after 1 in this decimal. It may be like this, the 0.200001 and 0.100002. So the compiler may give the output of 0.300003. So this value is not totally equal to 0.3. The compiler has some confusion here and so it will print the output no. In order to prevent this, what should we do is we need to call a float absolute function present in C. Let me show you that. So what should we do is we take double a is equal to 0.2 plus 0.1. This part is same. Now what we have to check is if float absolute function of a minus 0.3 is lesser than 0.000001 perhaps, then we should print yes, else no. So what this program does is it calculates the absolute value of a and subtracts 0.3 from it. If it turns out to be lesser than this value, which is not entirely 0 but almost tending to 0, then the program will print yes, else it will print no. This depends from compiler to compiler that how many zeros can you put here. The more numbers of zeros you put, the more chances are of your output being yes. This is one of the most interesting things in C. It varies from compiler to compiler. And people, mostly new programmers, are very prone to having this kind of mistakes. Let's see the third mistake, narrowing and format specifiers in C. So guys, what's narrowing? In the first example, I told you about how C implicitly typecasts a double value to an int and discards the values after a decimal point. For example, if I take double A equals 9.52 and store int B equals A, then this is allowed in C programming. This section is allowed. We can assign a double variable to an int. But what will this do is, the variable B will store the value of 9 only. It will truncate the 0.52 right there. So that leads to data loss. This phenomenon itself is called narrowing. Java doesn't let us do narrowing because in Java we can't do this operation. In Java, if we want to do this, we have to externally typecast int over here. Like this. Int B equals int of A. Without this, the Java compiler would not let us assign A to B, which the C compiler does, leading to many number of mistakes. Now let's see how we do a very common error related to format specifier. Suppose we have two values, double A equals 9.52, double B equals 2.73. Now let's store this value in an int variable. Int C equals A star B. Now if I print C using the format specifier of decimal or integer, then what will be the output? Here the output will be 25. As we all can guess, this leads to a data loss because the digits after the decimal point in 25 are truncated and it only returns 25 to us. Now the most interesting part, if we write printf %f, which is the format specifier for floating point and decimals, then what do we get? Very interestingly, we get 0.00000 like this. Why does this happen? Because as we multiply two doubles here and we store them in an integer, we can't use the integer with the format specifier of float. As soon as we use an integer variable with the format specifier of float, it will return gibberish like 0.000. Maybe in some compilers, the program will crash. It may not give error, it will not give any error, but the program will crash. Suppose if I have a simple thing like int a equal to 8 and I try to print %f a, this also will give the output of 0.0000. Most people, maximum number of people tend to make this kind of mistakes. Remember, in C compilers, the C compiler most of the time behaves unexpectedly. You can't have the little space of making this kind of mistakes because the program output will change drastically due to that. Now, if we wanted to get the correct output in this case, what should we write? Let's check it out. First of all, we should store the result in a double variable, double C. Now, as both of these variables are double, we may not typecast it, or we can, that won't matter. So we are just not typecasting it externally, and we are storing A into B in C. And now, printing with the correct format specifier. Only this will give the actual output of what should happen. It may give 25 point something 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 last 6. At last, it will give the decimal point accurately. So this is what I'm telling you guys. Data types are one of the most important aspects, especially in C programming. Because in C programming, we can't afford mistakes related to data types, which will change the output drastically very much, and we will never be able to find out what mistake did we actually make in the program, because the logic is totally correct. And this is prevented a bit in Python, because in Python, we don't use data types itself. In Python, there exists no data types. All the numbers over there from 0, 1, 2, 3, be it 1000, 2000, any number, they are not treated as integer itself. All of the numbers are treated as objects in Python. If we write, suppose a equals 3 in Python, then the variable a is assigned the object 3. 3 is not an integer here, 3 is just an object. Now if we write b equals a, then both b and a are instances which reference to the object number 3. Suppose I'm showing you by an example in Python. If I write a equals 3, then the variable a is assigned the object 3. 3 is an object here. This object belongs to a class of integers. 3 is not a primitive data type unlike C programming or Java. Now if I change a equals hello, if we do this in C programming, this will be a tremendous error, tremendous error. But in Python, this is nothing. In this step, the variable a is a reference to the object 3. And in the next step, we turn the variable a to a reference to the object hello. Now the variable a no more references the object 3 and it references the object hello, which is a string. And in the very next step, we can do like this. A is equal to 9.28612. Now the variable a references to an object 9.28612, which is an object of class double float. So while we work in Python, Python implements dynamic typing, unlike C and Java, which implements static typing. That is, once a variable is assigned a value, int a equal to 3, then we can't change the data type of that variable, never. We can typecast it, but we can't change the interior data type of the variable because they deal directly in memory. The C compiler goes in memory, it picks up 4 bytes of space and assigns an integer to it. While in Python, Python doesn't deal with memory directly. It just takes the object from an integer class and assigns a reference to it to a variable. So in the next video, I'm going to talk about this dynamic typing phenomena in Python and how is it useful and what are the disadvantages of it. Stay tuned. I'll see you in the next video. Thank you.